Okay, welcome back. Okay, so today we will continue with the new subtopic 2.2, charging and also discharging of the capacitor. Okay, so first we learn time constant first. Okay, so the product of R is the resistor, C is the capacitor, is known as the time constant. So we can write as time constant equals to RC. Okay, and it is a scalar quantity. Okay, it's a scalar quantity, meaning that we only consider the magnitude without direction. Okay, so its dimension is the dimensions of times. Okay, it's the dimension of times. So therefore, the unit that we use for time constant is we use second. Okay, so what is the meaning of time constant? Time constant, it is a measurement. Okay, it's a measurement of how quickly the capacitor charges or discharges. Okay, so we are referring to the time. Okay, time of the capacitor charging or discharging process. Okay, okay. Next we go to definitions of time constant. So we have two process here. One is a charging process. Another one is a discharging process. Okay. So time constant, now we have two definitions. Two meaning. Okay. For a charging process, the meaning is the time constant is defined as the time required for the capacitor to reach 1 over exponential negative 1. Okay. So to reach this value, or we can write as 0.63 or 63% of its maximum charge. Okay. Or the maximum voltage. Okay. So for example, so when charging process, initially there's no charge. Okay. So when we on the power supply, the charge is slowly flowing through into the capacitor. Okay, so the charge is increasing until the maximum value inside the capacitor. Okay, so we want to know, when time constant. So when the maximum value, okay, for example, the maximum value is 1. Okay, 1 coulomb. So we want to find when time constant, okay, equals RC, at that moment, our charge at that moment is 0.63% or 0.63. Okay, 63% at that moment. Okay, that charge that stored inside the capacitor. Okay, so from here we can find the time constant. Okay, if let's say for discharging process, okay, so after you charge until full and then you off the power supply. So when you off the power supply, okay, the charge inside the capacitor will slowly reduce. So it reduce until finish. Okay, so this is the graph. Okay, where the charge inside the capacitor is slowly reduced. So time constant for discharging process is defined as the time required for the charge or the voltage to decrease to 1 over exponential, or if you press calculator, is equals to 0.37 or 37%, okay, of the initial value. So if you want to find the time constant for discharging, we will find 0.37%, 0.37 or 37% of the total charge. Okay, and then from there you'll find that this is the time taken. Okay, this is the time taken when the charge, okay, at the inside the capacitor still have 37%. So this is the time taken for it reduce until 37% of the initial value. Okay, so there's a two definition for charging and also discharging process. Okay, so we continue. Okay, the time constant. Okay, so we continue. So the time constant is defined as the time, okay, time required for the current decrease to 37% of its initial value. Okay, so this is the time constant for discharging process. So this is the for discharging process. Okay, if let's say for charging process, meaning that it is the time taken for the capacitor to reach, okay, to reach 63% of its maximum charges. Okay, if let's say you want to say discharging, meaning that the time required for the charge to decrease from 100% decrease to 37%. Okay, so this is the difference between the charging and also discharging process for time constant. Okay, so we look at this, okay, we look at the YouTube here. Okay, so we play again. Okay, so initially, okay, if you look at this one, this is a charging process. So initially, there's no the equal. So after when we on the switch, okay, there's a power supply here. You see here is a power supply. The negative charge will flow, flow to the other plate. Okay, so if you refer to this graph, okay, the charge, the Q is increasing. Okay, is increasing. Okay, so this is the graph where the charging process. Okay, so at the positive plate, here will become more positive. Okay, it will become more positive at the upper plate. Whereas for a lower plate will become more negative. Okay, so meaning that there is a potential difference across the capacitor. Okay, there's a potential difference. Initially, it's balanced. Okay, there's no potential difference. Okay, but after when we on the power supply, the charge from a negative charge will flow slowly to the positive plate. Okay, so to the negative plate, sorry. So here will become positive plate and the bottom plate will become a negative plate. Okay, so there will be a negative charge at the bottom. Okay, and slowly when it is fully charged, you see the time taken to reach the maximum. Okay, it becomes slowly. Okay, it can become slower a bit. Okay, next we go to the discharging process. Okay, we go to the discharging process. So if you refer to the discharging process, okay, so when you refer to the discharging process, okay, wait. Okay, okay, you connect you to the YouTube. Okay, wait. Okay, when we come to the discharging process, okay, wait, okay. So initially, if you refer to the graph, okay, initially, when you refer to the graph, okay, initially there is a positive charge at the upper plate and at the bottom there's a negative charge. Okay, so this is what we mean fully charged. Okay, so at that moment, there's a potential difference and you see the power supply already taken out. Okay, meaning that there's no power supply. So what happened is this negative charge will flow in opposite direction. Okay, in opposite direction. Just now is from is a anti-clockwise. Now it flow clockwise, go back to the positive charge to neutralize. Okay, to neutralize negative positive, it will neutralize. Okay, so if you refer here, initially it will move faster. After that, when it is almost fully neutralized, okay, it's almost fully discharging, it will become slower. Okay, so if you look at the process, okay, so the charge initially is flowing faster. After that, okay, it will flow slower a bit because at that moment it is almost fully discharging. Okay, so negative positive it will neutralize by themselves. It will neutralize by themselves because positive negative it will neutralize by themselves. So when they neutralize by themselves, meaning that there is no extra charges inside the capacitor. Okay, and when it's fully neutralized, meaning that the potential difference between them is equals to almost zero. Okay, and the last one will move even slower. Okay, so this is the charge that move, because if you refer to the graph of course is okay, will move slower, okay, will decrease slowly. So this is the discharging process. You can refer to the YouTube. Okay, you can refer to the YouTube. Okay, so we will continue with the charging and also discharging process. Okay, you can refer to the YouTube. Okay, so I will continue. Okay, so this is 2.2b. 2.2b is a charging process. Okay, it's a charging process. Okay, so this is a charging process. So I explain first what is the charging process. So initially the capacitor is neutral, meaning that there's no charges inside the capacitor. Initially it's neutral. Okay, meaning that positive negative is equally the same for both plate. Okay, meaning that both plate A and B have both charges, okay, equally. Okay, because we know that positive negative it will neutralize by themselves. So when the S switch is closed, meaning that the current will start to flow and the electron will start to flow. So electron will start to flow from where? Electron will start to flow from a negative terminal, whereas, okay, of the battery and accumulate on the plate B. Okay, meaning that electron from plate just now, plate A, it will go to plate B. Okay, it will go to plate B. As electrons accumulate on the plate B, they will repel the electrons on the plate A. Okay, it will repel. Like just now the video clip. This electron will flow into the positive terminal of the battery through the resistor. Okay, through the resistor here. Okay, leaving a positive charge on the plate A. Okay, because initially is equally, but now the electron is going out from plate A to B, from A to B, from A to B. So the remaining charge is still positive only. Only positive. Okay, only positive charge on plate A. Okay, as the charges accumulate on the capacitor, the potential difference will also increase. Okay, because there's a difference between the plate A and also plate B. So that's why the potential difference will increase. Okay, and the current is reduced until eventually the maximum voltage across the capacitor equals to the voltage supply. Okay, okay. As this time, no further current will flow through the capacitor, and the capacitor is okay when it is fully charged, meaning that there's no current flowing through. Okay, next. Okay, so this is the graph. Okay, so I explain again. Okay, I explain again. So initially there's a charge inside the plate A and B is balanced. Okay, it's balanced. So when your power supply is when the switch is on, okay, this is the current come out from terminal positive, but the electron will come out from terminal negative. Okay, current will flow from terminal positive, electron will come out from terminal negative. Okay, so when the switch is on, the electron from here, it will flow through the resistor. Okay, will flow through the power supply, and then it will go to plate B. So meaning that your plate B, slowly it become negative charge at here. Okay, and only left positive charge at plate A. Okay, so meaning that this is what we say potential difference across the capacitor. Okay, so okay, this is the graph that we will get. This is the graph that we will get. Okay, so this is the graph. Okay, initially there's no charges inside the capacitor. Okay, when the power supply is on, the charge one by one, it will store inside the capacitor. Okay, it will store inside the capacitor. Of course, your V here is, of course, we are referring to VC. Potential difference across the capacitor will slowly increase. Okay, because positive negative is very obvious on plate A and also plate B. Okay, however, our current is reducing. Why the current is reducing? Because your current is equal to dq over dt. dq over dt meaning that the rate of charge flow. When the charge flowing, there will be a current. So initially the charge is flowing very fast. Okay, very fast. So initially the charge, because there's a potential difference. So when there's a potential difference, the charge is start to flow. Okay, the charge will start to flow until when the charge is fully charging on the capacitor, the charge will become slower. So when the charge flow becomes slower, your current also will reduce. Okay, will reduce. So until there's no, when it's fully charged, when no charge is flowing through the the negative plate. Okay, so there's at that moment current also equals to zero. Okay, so meaning that the current is depends on the charge flow. Okay, depends on the charge flow. Okay, next we go to the discharging process. Okay, we go to the discharging process. So when we go to discharging process, if you refer here, okay, there's no power supply. Meaning that the battery is taken out. Okay, we taken out the battery. Okay, so when there's no battery, meaning that discharging process. Okay, when there's no battery, we take out, we disconnected with the battery. That moment is the discharging process. So when just now when it is fully charged, where plate A is positive, plate B is negative, at that moment there is a potential. There is a potential difference across A and B. Okay, so during the discharging process, this is the keywords. Okay, this is the keywords. During the discharging process, when the question said the battery is disconnected, meaning that discharging process. Okay, usually the question will say battery is disconnected, meaning that the battery is taken out. Okay, there's no power supply. So at that moment, you must know, okay, that is the discharging process. So when the switch S is closed, electron from plate B. Okay, electron from plate B just now is fully charged. Here a lot of electron will begin to flow through the resistor to neutralize. This is the keywords. Okay, it will neutralize the positive charge at plate A. Okay, so initially here there's a lot of electron at the plate B. Okay, so what happens when we on the switch is the electron, it will flow in opposite direction. Now this is in clockwise. It will flow back to neutralize, okay, to neutralize the charge positive. Okay, because we know positive negative, it will neutralize. Okay, it will neutralize. So when it's neutralized, meaning that there's no extra charges, the potential difference also will decrease. So initially, the potential difference across the capacitor is maximum initially, because positive and negative is separated. And a maximum current flow through a resistor R. Okay, so similar, when your electron is flowing in clockwise, meaning that your current come out from positive, it will flowing in opposite direction. It will flow in anti-clockwise direction. Okay, so when part of the positive charges on the plate A is neutralized by the electron, the voltage across the capacitor is reduced. Okay, because it's already neutralized, meaning that the potential difference across the two plates is reduced. Okay, and the process continue until the current through the resistor is become zero. Why become zero? Okay, because your current is depends on dq over dt, the rate of charge flow. Okay, so initially there's a lot of electron at here. So electron will slowly move from plate B to A, plate B to A. Okay, but slowly when plate A is almost fully neutralized, almost fully discharged, the charge flowing to plate A will slowly decrease. Then the speed will slowly decrease. So when the speed of the charge slowly decrease until there's no extra charges, there's no more charges flowing from plate B to A. Okay, where it is fully discharging, where it is fully neutralizing. Okay, so at that moment there's no charge flowing. So at that moment you will get your current is equal to 0. Okay, at that moment you will get that your find out that the current at that moment is equals to 0. Okay, when there's no charge flowing at that moment. So at this moment, all the charges at plate A is fully neutralized. Okay, it's fully neutralized and the voltage across the capacitor becomes 0 at that moment because already fully neutralized. So this is the graph. This is the graph. Okay, so this is the graph where initially the charge is fully discharging. Okay, it's fully charged. So when it is fully charged, okay, we take out the battery or the battery is disconnected from the circuit. What happens is discharging process will begin. So the charge will the electron will slowly from plate B to A, okay, to neutralize the positive charge in the plate. Okay, until it is fully discharging, until it is fully neutralized. So similar for your voltage, your voltage also will decrease until it is fully neutralized, so it will reduce. Okay, whereas for your current, so current, as I mentioned, is equals to dq over dt. So it depends on the rate of the charge flow. When the charge is flowing, there's a current. If there's no charge flowing through, there's no current. Okay, so initially when it is fully charged, okay, so the electron will flow faster through plate B to plate A, fully to neutralize the positive charge. Okay, so the current is flowing. Now when the charges is flowing through plate B to A until it is fully discharging, until it's fully neutralized. So at that moment, no charge is flowing. At that moment, your I will equals to 0 because there's no charge is flowing. Okay, why the graph is opposite? Just now for the charging process, current is in this direction. Okay, so this is for a charging process. Okay, current versus time. But for discharging process, the current in this direction. Okay, is for discharging. Okay, why one is charging is at positive and discharging at negative. Okay, this is because of the direction. Okay, it's because of the direction. Okay, if you refer the charging process. Okay, if you refer to the charging process. Okay, just now the current is come out from terminal positive, meaning that just now the current I is in clockwise. Okay, this is charging process. Okay, but for discharging process, I is in opposite direction. Okay, your I is in anti-clockwise. Anti-clockwise. So meaning that the directions of I charging and discharging is totally different. It's in opposite direction. So that's why charging positive, okay, because it flow in just now is in clockwise, okay, and then discharging is in anti-clockwise. So that's why the graph one is at the upper, one is at below the x-axis. Okay, so this is the difference. Okay, now we go to the equation. Okay, for charging process, we can write the equations for Q. Okay, for charging process, we can write as Q, okay, equals to Q naught 1 minus exponential negative T over RC. Okay, and your V similar, your V you're referring to V capacitor equals to V naught 1 minus exponential negative T over RC. Okay, for current is I equals to I naught exponential negative T over RC. Okay, so you may pause the video if let's say you cannot follow. Okay, you may pause the video to copy down the equation. So this is for charging process. Okay, charging process. So charging process, your Q is increasing, your V is increasing, but your current is reducing because depends on the charge flow. Okay, for discharging process. Okay, for discharging process, initially there's a charge inside the capacitor. So when we taken out the battery is disconnected, your charge is reducing, your potential difference across the capacitor also will reduce. Okay, so our equation is Q equals to Q naught exponential negative T over RC, and your VC also equals to V naught exponential negative T over RC. Okay, I will equals to negative. Negative here actually shows the direction. Direction is opposite direction. Okay, direction is opposite with the initial. Okay, charging and discharging process. So equals to negative I naught exponential negative T over RC. Okay, so this is the difference. Okay, so here there's an explanation here. Okay, the explanation say that the negative charge, the negative sign, okay, the negative sign indicate that the capacitor is discharged. The current direction, the direction is opposite to the directions where the capacitor is being charged. So the negative here shows the directions of charging and discharging. The current of the charging and discharging process is opposite only. Okay, so we try questions example number 4. Okay, we try example number 4. Okay, here we have two capacitor. C1 is 50 microfarad, C2 is 25, and V here we are referring to the battery, 25 volt. So C1 first charging process by closing S1. Okay, by closing S1, and then S1 is open. Then the charge capacitor is connected to the uncharged capacitor. This is important, uncharged capacitor, meaning that initially C2 is zero charge by closing S2. Okay, so after that S1 is open, we connect with S2. Okay, so calculate the initial charge acquired by C1 and the final charge on each capacitor. Okay, so this question actually it can split into two parts. Okay, the first part is only C1. Okay, with the battery. Okay, because it's connected with S1. S1 closed, but S2 is open. So S2 open meaning that the whole circuit here, okay, the whole circuit is disconnected. So this is because there is a battery here, meaning that the first one is charging process. Okay, it's charging process. Okay, so after that, switch S is then open. So when the switch S is open, meaning that this part on your left hand side is disconnected. Okay, so we can just ignore it. Okay, so when the switch S1 is open, meaning that the battery is disconnected. Okay, when the battery disconnected, meaning that discharging process happen. Okay, when the battery is disconnected, when the battery is taken out. So the next process is only C2 and C1. Okay, and the battery at here already taken out. Okay, so we label this one as S2. Okay, so first we must find charge stored in C1 when it is charging process. Okay, so we know that our V for the power supply is 25. So your V supply is equals to 25 volt. Okay, is equals to 25 volt. Okay, so how can we find the charge stored in the capacitor? Okay, so by using the formula, Q equals to CV. Okay, where our C1 is 50 micro and your V is 25. So we find out that our charge initially is 1,250 microcoulomb. Okay, so this is charging process. When it's fully charged, there is a 1,250 microcoulomb stored inside here. Okay, so I write here After charging, we have 1,250 microcoulomb store. Okay, but at that moment, your C2 is uncharged, meaning that at that moment, Q2 is equal to 0. Okay, 0 coulomb. This is your Q1. Okay, okay. After that, what happened is, your C1 and C2 is connected. There's a potential difference across C1 and C2. Okay, there's a potential difference across C1 and C2. If you calculate that initially, after that, okay, we can calculate V1 is equals to Q1 over C1. So at that moment, your V1, your Q is 1250 micro, and your C1 is equals to 50 micro. So your V1 is 25 volt. But at that moment, your V2, because equals to Q over C, and your Q is 0 because the question says it's uncharged, over 25 micro. So at that moment, it is equals to 0 volt. Meaning that what happened is there is a potential difference across C1 and also C2. Okay, there's a potential difference across C1 and C2. Okay, tak balance Okay, satu sangat kaya. Okay, sangat-sangat kaya. Kaya meaning that at that time we have 1,250 charge inside here. Okay, there's a 1,000. Okay, 1,000. Okay, at that moment your Q is 1,250. Okay, so here initially, and this C2 is very poor, no charge inside. Okay, what happened is there's a potential difference. So when there's a potential difference, meaning that high potential will go to the low potential. Okay, so ni orang kaya lah, ni C1 ini dia banyak charge 1,250. C2 ini dia miskin, kosong tak ada duit langsung. So apa yang berlaku? Okay, what should he do is dia akan donate sikit lah. Okay, dia akan donate charge dia. Okay, donate sampai bila? Donate until no potential difference. So this is the keyword. Okay, because initially it is not balanced because it's 25 and also 0 volt. So there's a potential difference across them. So what happened is C1 it will donate its charge. Dia akan demar dia punya charge. Okay, demar until bila? Demar until, okay, it will donate until there's no potential difference. So this is the keywords here. Okay, every time when you want to do this type of questions, you must remember when there's a potential difference, 25 and also 0, what happened is discharging process because there's a potential difference. So discharging process will happen, meaning that the charge will flow. Okay, the charge will flow. Okay, from C1 to C2, beri sikit lah. Okay, beri sikit because when the charge increase, of course C is constant. When the charge increase, of course your V increase. Okay, similar for your V1. When the charge reduce because it's donate, okay, it's reduced. Okay, wait, it's reduced. Wait, I write first. Okay, so when the Q is C1 is reduced, okay, is reduced. This C1 of course is constant. What happened is your V1 also will reduce. Okay, so when discharging process happen, okay, when it will stop? When V1 equals to V2. Okay, when V1 equals to V2. Okay, when V1 equals to V2. So this is the keywords. Okay, it cannot donate everything to C2. Okay, so what happened is they will only discharging until there's no potential difference across C1 and also C2. Okay, so this is the things that you need to know. Okay, so every time when you want to do this type of questions, you must find when V1 equals to V2, meaning that this is a parallel process. Okay, because V1 equals to V2 is a parallel. Okay, we cannot use series, although it seems like it is series. Actually, this is a junction. Okay, it's a junction. Okay, so we cannot use parallel to solve these questions. And we must use, we cannot use series to solve this question because this is a parallel case. We must let V1 equals to V2. So we must use parallel parallel to find the C effective, Q effective, and V effective. Okay, so we continue. We know that this is a parallel case. So every time when you want to solve this type of questions, you must find everything total first. So our Q total is equals to, because it's parallel, so it's Q1 plus Q2. Okay, you refer back to the parallel case. So Q1 initially we have 1,250 micro plus 0. So you will get 1,250 microcoulomb. Okay, how about C total? Because this is a parallel, so C total is C1 plus C2. Okay, where we have 50 micro plus 25 microfarad. So we will have 75 microfarad. Okay, so when we have Q total, C total, we can find V total. So our V total is equals to Q total over C total. Q total is 1,500 micro and your C total is 75 micro. So meaning that your vote is 16.7 vote, 16.7. Okay, so meaning that initially is not balanced, 25 and 0. So what happened is it will reduce until 16.7 and this C2 will increase until 16.7. Okay, so meaning that V total is equals to your V1 equals to your V2 because it's parallel and is equals to 16.7 volt. Okay, but the question asks us to find the charge. Okay, the question asks us to find the charge. So we want to find Q1. Okay, Q1, of course, you must use C1, V1. Okay, so C1 is 50 micro and your V1 is 16.7. So your Q1 is equals to 835 microcoulomb. Okay, Q2, of course, you must use C2, V2. So C2 is 25 micro and V2 is 16.7. Okay, 16.7. Okay, so when we say 16.7, you press the calculator. Okay, you press the calculator. Okay, you press the calculator and you will get answer is 415 microcoulomb. Okay, or the other way, you can also use Q total equals to Q1 plus Q2. This is optional. So Q total is 1250 micro equals to Q1 is 835 micro plus Q2. So you will also get finally your Q2 is equals to 415 microcoulomb. Okay, so this is the final charge stored inside the capacitor. Okay, so we have okay, so example 5 and example 5 is your example 5 is your homework. Okay, so I will go to examples. Okay, maybe I will discuss okay, example 5 is your homework. Maybe I will discuss example 6. Okay, because example 5 is almost similar with the example 4. Okay, so example 5 is your homework. Okay, it's your homework. So I will continue with your example 6. Okay, example 6. Okay, example 6 also charging and discharging. So when it connect to A, meaning that it is a charging process because there's a battery here. Okay, when this switch shift to B, meaning that there's a battery is taken out, is disconnected with the battery. So it depends on the questions. Okay, so in RC circuit shown in the figure, the battery has fully charged the capacitor. This is because it's connected with A. Okay, when it's connected with A, it is fully charged. So when the T goes to 0, the S is thrown from A to B. So when it's thrown to B, meaning that discharging process. Okay, it's a discharging process when it's connected with B. Okay, when the S is connected with B. meaning that the battery is already taken out. Okay, so we only have resistor and also capacitor. Okay, at that time, the battery voltage is 20 and the capacitor is 1.02 microfarad. Okay, the current I is observed to decrease to, initially, decrease to 0.5 of the initial value. Okay, in time taken, 40 microsecond. So the first one, determine the value for R. Okay, so this is a discharging process. Okay, this is a discharging process because we already disconnected with the battery. Okay, so when it is fully charged, when it is charging, when it is connected with point A, when it is fully charged, your VC here also equals to 20 when it is fully charged. Okay, when it is fully charged, is equals to 20. Okay, after that only we connect with B, then only discharging process happen, meaning that from 20 it will decrease. Okay, dia akan kurang from 20 volt, dia akan kurang until equals to 0. Okay, so we need to find the value for R. But we know that initially when I equals to I naught, okay, and then after T equals to, this is when T equals to 0. Okay, so when T equals to 40 microsecond, at that moment, your I already equals to 0.5 of the initial value. Okay, so for this charging process, okay, you can refer back. Our equation for this charging process is I equals to I naught exponential negative T over RC. Okay, here we do not put negative because we only want to find the value. Okay, negative just now for the charging is because of the directions. That's why we put negative. Okay, so I is the remaining. So at that moment, the remaining is 0.5 I naught. And initial is I naught. Exponential negative T is after 40 microsecond. R is the value that we want to find. C is 1.02 microfarad. Okay, so you can press calculator. I naught we cancel. Okay, I naught we cancel. So you can press calculator. Ln 0.5 equals to negative. Okay, negative 40 micro over R 1.02 micro. So micro we can cancel. Okay, so finally our R you will get 57 ohm. Okay, because this is a discharging process. Okay, next we want to find the time constant. Okay, you may pause the video if let's say I'm going too fast. Okay, then you can do press calculator first. Okay, time constant. What is the equation for time constant? Time constant is equal to RC. Okay, where R just now we get 57 and C is 1.02 micro. Okay, so you will get your time constant is 5.8 times 10 to the power of negative 5 second. Okay, because it's the time, so we put unit in second. Okay, find the value of charge Q when T equals to 0. Meaning that when T equals to 0, before it starts discharging, it is fully charging. Okay, so Q equals to CV. Okay, so your C is 1.02 micro. And V, when it's fully charged, okay, when it's connected with A, when it's fully charged, your VC is equals to your battery charge, okay, the voltage, so it's equals to 20. So when it is fully charged, the charge inside can store into the capacitor is 2.04 times 10 to the power of negative 5 coulomb. Okay, where it is fully charged, okay, before it's discharging. Okay, next, the value of Q at T equals to, okay, so initially when T equals to 0, we have Q naught. So our Q naught at that moment is 2.04 times 10 to the power of negative 5 coulomb. Okay, after T equals to 60 microsecond, we want to find at that time the remaining charge, okay, the remaining charge that's still stored inside the capacitor. Okay, So because this is a discharging process, so our Q will equals to Q naught exponential negative T over RC. Okay, so Q is the remaining that we want to find at that moment. Q naught is 2.04 times 10 to the power negative 5. And exponential T is 60 micro. And then your RC is, you substitute 5.8 times 10 to the power negative 5. Okay, so you will find out that the Q that remain after 60 microsecond is 7.3 times 10 to the power of negative 6 coulomb. Okay, so this is the remaining charge that stored inside the capacitor after 60 microsecond. Okay, so that's all for subtopic 2.2. Okay, thank you class, and we will continue with the next video with the final subtopic 2.3. Okay, thank you very much.